in tutorial, you found the magnetic field due to a loop. And the way they did that is by looking at a loop as a series of straight wires. Well, let's first of all concentrate on the current in that top wire. Paint it red. Now, my right-hand rule number 2, I put my thumb in the direction of the current. The field's going to go into the board at the top and out of the board down here. Okay? Into the board up there, out of the board there. Then I look at this piece here. If conventional current's going over there to the left, it's got to come down. And that means that my thumb has to point down. And that means that the B field is going to be into the board out there, out of the board in here. Okay? Then I look at this wire here. It's going to the right, so that's going to give me out of the board up there, and this is a little hard to do without breaking my wrist, into the board down there. Okay? And that last one is just the same. Now, what I have are a bunch of field lines that come out of the center and then wrap back around outside. They come out of the center and then wrap back around. Well, that looks familiar. Now I'm going to turn that this way. Okay? As if let's let this represent the loop. I'm going to turn it that way. Okay? Now, if a whole bunch of field lines are coming out towards you, imagine that coming out towards you. When I turn this way, those field lines are going to be pointing towards the open door, are they not? So I'm going to rotate that, and that's what it looks like. Well, let's think about this. The current's going to the right here. If I rotate that, the current at the bottom would be going what direction? Away. The current at the top is going to the left. If I turn this like that, that's coming towards you. And that's what I'm representing here. Think of this as a donut. I wish I had thought to bring a donut. I'm hungry. But if I had a donut and I broke it in half, this represents the back half of the donut. We've taken a cross-section of our loop. And what this says is that current is going away from you at the bottom, up the back, and out the top. Okay, like that. Okay? And what we find is that the field lines are going to the left on the outside, and they're going to the right on the inside. Okay? Think of that again. They were coming towards you in the center. I turn that and they're going towards the open door. They're going away from you outside the loop. I turn that and they're going away from the open door. Make sense? Now, that field you've seen before. It is the field of a bar magnet. And that means that I can replace a current loop with a little bar magnet. I can define a north side of that loop and a south side of that loop. And the way I remember which side is north and which side is south is right-hand rule number 3. Okay, that's my last right-hand rule. That's the good news. It's the last one. Now, here's my message to you. Problems involving current loops are hard, are incredibly hard, until you replace that loop with a little bar magnet. And then you just remember what you learned in the 3rd grade. If I had a little bar magnet here and it was free to rotate, which way would it rotate? As soon as you replace a loop with a bar magnet, every single one of those problems become trivial if you think like a 3rd grader. Okay? Now, There's a current loop. Those are the field lines. They're coming out of the left of the loop and going into the right of the loop. Kind of like that. And those are the fields that we got when we had a bar magnet. And so we think of that current loop as a bar magnet. Okay?